guys, so we're in the middle of our nuclear chemistry unit, and I know that we're not doing Regents level stuff right now, but what I'm trying to do is I'm trying to find you some interesting articles that give you some insight into different types of chemistry that we would not have been able to talk about in the classroom because we would have been writing chemical formulas. But this is a kind of an interesting thing, and I think what I'll do for the next couple of weeks is I'll give you some chemistry of infographics, and we'll go through them real quick. And then I'm going to give you an article on the chemistry of gold, and you can take a couple days to take a look at it. So just wanted to look at this with you. Obviously it says chemistry of gold up there on the top. And you can see some of these properties and some of the things that we've talked about in the past. So the gold is plastic, and that simply means that the electrons can slide past one another. It's like a flexible, and you got this little doohickey thing here that shows you that you can move it around. So we talked about these words ductile and malleable in class. Ductile meaning you can make it into a wire. Malleable means it's bendable, so that we can see that with gold. Whoops, oh, I got two lines there. Pretty cool. All right, it's very conductive, and the reason why it is so conductive is because the electrons can move easily through. Remember, we have a sea of mobile electrons, so take a look at that. For the most part, gold is non-toxic. Now, if you go to a really fancy restaurant, this is kind of fun. Sometimes they put like gold flakes on top of your soup or a dessert. They're generally non-toxic. While metallic gold is non-toxic, if you have a compound of gold, so the compound contains the ions, that can be highly toxic. So while you have metallic gold, you eat it, it comes out the other end, nothing happens to you. If you have a compound of gold, it can be highly toxic. That's kind of an interesting fact. All right, we got gold has a high boiling point, okay, and it's because, remember we talked a little bit about intermolecular forces of attraction? Well, they have very strong, the hugs are really strong, okay? Obviously, down here, let's see, I gotta go to this thing. It has metallic bonding, okay, metal to a metal, and you can see right here, you got a gold atom bonded to another gold atom, and then these electrons are moving in between these. Okay, I'll zoom out a little bit. Let's see, it's lustrous. That means it's shiny, and the light bounces off of it and produces like that shine that we all like when we talk about gold. It's expensive, okay, 3 to 4 parts per million in the Earth's crust, so it's fairly rare. And there was a video, I don't remember if we watched it this year or I watched it last year, where they took the tons and tons and tons of rocks out on the trucks, and they got, oh yeah, I think we did watch it this year, and they only got that little itty bitty bead of gold out of there. All right, unreactive, it doesn't react. Okay, it's unreactive, doesn't react with other things. That's why we can use it for jewelry. This one's a really cool thing. I don't know if you remember, but there's certain parts of the reference table that have color. And you'll notice that gold is atomic number 79 if you look at your reference table, and it's in the transition metals. So all of this stuff right here is 5D, suborbital, 6. So forget about that. It's yellow because it's in those transition metals, which is a really cool thing to know about gold. And I think that's pretty much it. Okay, let's see what it says down here. Gold atoms arranged in a highly regular structure because it's a solid at STP. And delocalized electrons, where they have that written down here, that simply means that you have electrons that are moving, a sea of mobile electrons. So I just thought you would like to take a look at this chemistry of gold, and I'm going to give you a few of these as we go through the rest of the next 4 to 5 weeks that we have together. You guys are doing a really great job. Keep it up. Just watch the videos. Do the best you can on those questions. I'm going to give you 2 days to do this chemistry of gold article and how it relates to nuclear chemistry. And then we're going to watch something on Chernobyl, and I'll talk to you at the end of the week.